So this is the easy thing for May 1st. So every row and every column and every 3x3 box has contained 1 to 9 watts each. So I've got a 1 here and a 1 here. The 1 in row 3 is in the middle. The 1 in row 1 is in the top. The 1 in row 1 is in the top. The 1 in row 3 is in the bottom. The 1 in row 2 must therefore be in the middle, and it has to be in box 1. And there's only one spot for it, right there. I've got two 2s. Column 3 must be in the top, but it can't go there because of this 2. So that's a write-in. Let's see. I have a bunch of 5s. I don't have 3 or 4. I have 1 4. And I think I've done all my digits there. Let's see. These 3 cells in column 1, I only have 2 options left. They're from 6, 7, and 8. This one can't be 6. It can't be 7. So this is 6 or 8, but I don't know anything else beyond that. This one can't be 8. It's 6 or 7. This one can't be 8. Can't be 8 or 6. So this is actually 7, and that's a write-in, which makes this 6, because it can't be 7, and therefore this one must be 8. Now, in box 2, I'm down to 2 cells left, 4 or 9, neither of which are resolved, because I don't have a 4 or 9 in the respective row or column, actually. So 4 or 9 here. That makes these two a 3-7 pair, neither of which appear to be resolved. These two are 3-7. That means these two are 4 and 6, and because of this 6, I know the order. That must be 4, that must be 6. Now, I've got 2 6s here. There's a 6 and there's a 6. 6 in column 2 is now in one of 3 places, but I don't know anything beyond that. The 4 in row 1 is still in one of these places, and it's not resolved yet. Let's see. I think I've done all I can there. Let's see if I can't do anything here. I've got 2 5s in the last 3 rows. There must be a 5 actually in the middle, and that's a write-in. Actually, although Sudoku would have done it because this 5 rules that out, and there's a 9 on there already. Let's see, this one's down to 5, this one's down to 4. Let's see. This is 1, 4, 6, or 7, but it can't be 4 or 6. So this is 1 or 7. This being 1, 4, 6, or 7, but it can't be 1 or 4. So this is 6 or 7. This one, by the same logic, well, actually, it can't be 1 or 4 or 6. So this one is 7, which means that one's 6. That one's a 1, and the 4 must go there to complete the box. Essentially, I'd put down 2 candidates in a pair, and once I'd unraveled one of them, I basically, by process of elimination, figured out where every other cell in the box had to go. Now, these 2 cells in row 8 are the only ones left. These 2 must be 2 and 9, and thanks to this 9 down here, I know where that goes. Actually, no, I can't scan right. This is 2 or 8. Thanks to this 8, that's still 2, but that's 8, not 9. Okay. Now, these 3 cells left are the last thing I need in box 8. I'm missing 1, 6, and 7. This can't be 1 or 6, it must be 7. And therefore that must be 1, because it can't be 6 or 7. This one must be 6 to complete the box. Okay. Now, since I've got row 8 done and box 8 and 9 done, I should be able to finish these out just by Sudoku. Let's see. I don't have 1s in this box, but there's a 1 and there's a 1. Row 9 has to be in the bottom, but it can't go there, so it must go there. 2s are the same way. It must go in the bottom, so it's forced to go there. Let's see. These are now down to 4 or 8. And thanks to this 8, I know the order. Now, let's see. That 4 sorts out this 4-9 pair, which takes that out. Oh, this 7 sorts this out. Let's see. I've now made box 2 a 6-7 pair because there's a 7, there's a 7. 7 must be in the middle in row 2, but it can't go in column 4 because of this 7. So that's a 7 or that's a 7, and these two are also a 6. Well, if that's a 6-7 pair, that means this can't be 6. So I think that must be 9 because it's the only... must be 9 because that's the only thing that's left. Ooh, I already have one. Okay, that's a problem. What did I say? I think I'd ruled this one out to be 6. Well, let's see. These two, 1, 2, 3, 4, 5 already done. So this is 6 or 9, but this can't be 6. So in fact, this must be 9. Which makes this 6, and now I've got a problem here. This is not a 6-7 pair. And neither is that. Because I'd scanned that wrong. This is 7 or 8. And thanks to this 8, this is actually 7. But that's 8. Now, these two are down to 3 or 9. And I know the order. These 3 cells, actually, no, 4 cells in box 4, let's look at the column instead. 6 or 9, neither of which are resolved. These two, therefore, must be 3 and 7, but thanks to the 3, I know the order. That's missing a 7 to complete the box. The 7 in column 6 is now placed thanks to this 7 and this 7 ruling out here and here, and these two 7s ruling out the top and bottom rows respectively. Let's see, there's an 8, there's an 8. 8 must be in the top, but it can't go there, so that's an 8. 1 must therefore be in the top, and it completes that. Let's see. That's missing a 9 to complete the column. This is now missing a 3 to complete the box. This 9 sorts out that 6-9. That's missing a 4 to complete the row. That's missing a 6 to complete the box. And there we go.